Well, welcome to, and I normally would say workshop or playroom, but today I'm going to say laboratory. And it's because we're going to be doing some scientific tests to confirm the presence of magnesium. As you may or may not know, there were a number of machines back in the day that instead of being made out of steel or cast iron or aluminum, they were made out of magnesium. And the benefits of magnesium are significant. It's stronger than many steels, and it's lighter than aluminum, which is why a number of the manufacturers went to it. But the other factor is, chemically, it reacts differently to different conditions. For example, if a factory that's manufacturing magnesium sewing machine catches fire, you don't want to get anywhere near it, because it's not going to just be the danger of the fire, it's going to be the danger of the reaction of that magnesium to the flame. And we're going to actually look at that today during this premiere as we go about trying to confirm that the machine that I'm going to unveil here, in fact, is made out of magnesium. And I've already taken some scrapings of it, and I've got my old little laboratory set up. So let's get to it. But the other thing I'm going to show you is this machine is going to need a lot of help. More help than I ever imagined when I saw the still shots sent to me by Colleen Vonberg out of Connecticut. And I think they may be living in New York now. I lose track, but at least their phone number when I called it is Connecticut. So this is a machine that came out of Connecticut. The base was rotten, the wiring is rotten, the machine is rotten. It's just a rotten... I want to ring the bell. Yes, I do. Hold on. And I'll just show you kind of what I mean by the case. I got this and started to pull it out, and right away wanted to get a mask as I was looking at the condition, and there was mold on it, and just everything under the sun says, help, help. So let me lift this up and we'll actually take a look at this machine. And those of you that are real savvy, oh, I didn't even show the inside of this. Those of you that are real savvy are going to recognize it straight away until I block it again. Look at the inside of that case. I probably should have a mask on right now. Yeah. You're going to recognize that as a FREE-WESTINGHOUSE machine. And if you don't know already, FREE-WESTINGHOUSE has its roots. Well, let me just read you a little bit about their history. Kind of give you a foundation as we step into this. So the St. John's Sewing Machine Company, which was the predecessor of the Free Sewing Machine Company, was founded right around 1870. In 1883, it was renamed the Royal Sewing Machine Company. After the company relocated to Rockford, Illinois, it was renamed once again in 1897 as the Free Sewing Machine Company, after company president William C. Free. That's a fun name, isn't it? Say that about 20 times with a mouthful of Ritz crackers. William C. Free. Yeah, I can't even say it once. Most machines made at the Free Company were for sale by mail order. Does that make you think of another company? Yes, Sears and Roebuck. And then they also offered their machines at department stores. Now, these machines that were marked Illinois Sewing Machine Company were also made by Free. In the mid-1920s, Free became associated with Westinghouse, which became the sole supplier of motors and electric equipment for Free brand sewing machines. The Free-Westinghouse machine first appeared in 1926 after the Free Company became associated with Westinghouse as the sole supplier of electric motors to Free. The name was used until the 1950s. And the machine we're looking at that Colleen sent me is probably right around from the early to mid 1940s. And the serial numbers on these machines were not always horribly reliable to look up. No, they weren't. All right. Do you have your special glasses on, since we're going to be doing science experiments today? I hope you do. Now let me zoom in on this machine and I'll show you kind of how I got my scrapings. It was pretty easy because the machine is damaged. There's one of the areas I got some scrapings from. There's another area right over there. Finally, on the back corner, there's another area right there where I got some of my scrapings from. Now, magnesium is a tricky metal to work with. It's a very tricky metal to repair. It's an even trickier metal if you have to weld it. So this should be pretty doggone fun. Yeah, it should. Let me show you their branding mark first of all, which I think is super duper cool. And they've got pretty much the same thing on the inside of the pillar too. Yes, they do. Well, the first thing I'm going to show you is we've got, where am I? There I am. We've got a couple of containers or vials of different compositions. Vial number 1, and I could number them, but I'll just say that, okay? Vial number 1 has vinegar. Vial number 2 has scrapings from this machine, which we are suspecting is going to be magnesium. And lastly, I've got a vial of some good old-fashioned baking soda, just so we can see the different chemical reactions. That's kind of cool, huh? So let's get busy. The other thing I'll tell you is, and this is aluminum, by the way, the other thing I'll tell you is that aluminum, unlike magnesium, it melts, but it doesn't burn. In other words, it doesn't spark if you hit it with a flame. It also doesn't have an immediate reaction to baking soda. Not sure about baking powder. That's an interesting question. And down here in this little metal magnetic tray, I've got baking soda. There I've got our ignition source. I could also use my torch, but we might just go with a flame. I've got one of my dental tools, which is what I use to gather up the scrapings and to put them inside of that little vial that's in the middle. I've got my handy dandy little brush, and then I've got a neat little syringe with an interesting tip on the end that Emma sent me from Florida. I had my own, but I didn't have the cool little tip. So guess what? Now I got a cool little tip, and it looks like it's dripping vinegar, which is what I'm going to put in there. And I already have put some in there too. So what else? Yeah, that's probably enough. So let's first of all see what happens if you don't remember from science class 150 years ago when you were in school, like me. Let's see what happens to good old-fashioned baking soda when we add vinegar to it. All right, are you ready for this? Again, you got your safety goggles on, right? I hope you do. So, we're going to take some of our good old-fashioned vinegar, and this is not apple cider vinegar or anything fancy like that. It's just basic old vinegar. All right, so we're going to put a couple drops or plops or drips or whatever into this stuff and see what happens. Again, it kind of takes us back to our science classes, doesn't it? All right, here we go. Well, let's mix it like this since I totally missed it. Ah! Try it again, Scott. Try it again. I'm not used to these fancy syringes that Emma sent me. So if you didn't remember that from science class, it kind of bubbles up a little bit, doesn't it? I'll kind of move it around a little bit with my dental tool, try to get it to react to the rest of this stuff. Nothing like the smell of vinegar, is there? It just has a smell unto itself, doesn't it? So anyway, you get the idea. We had a chemical reaction. It kind of bubbled up, didn't it? Well, if what I have in that little middle vial that you saw is in fact magnesium, unlike aluminum, it's going to have a reaction, probably not quite as animated as the baking soda, but it's still going to have a reaction. So I'm going to set this to the back, and I'm going to grab our little vial of magnesium shavings. Adjust my camera just a little bit. And I'm going to see if I can control this syringe this time better than I did the first time and add just a little bit of vinegar to the shavings that are in this little vial thing. Again, we should get some sort of a chemical reaction. Again, it may not be as dramatic as when we hit it with fire, but it'll probably do something. Let me check my shot just to make sure we've got a clear view of it. Yeah, we'll zoom in even a little bit closer, okay? So again, I scraped this off of the edges of Colleen's machine where it was already damaged. And now we're going to see if we can get a chemical reaction from this. Again, it's going to be fairly subtle, but we should get something, hopefully. All right, here we go. Oh yeah, it did react a little bit. Put a little bit more in there. Thought I had more in the syringe, but I didn't. Oh, there we go. We're even getting like some sort of a mist or foam off of it too. Well, that confirms the presence of magnesium. Magnesium reacts to vinegar. Aluminum does not. That's pretty daggone cool, isn't it? And it's a different reaction. You saw it's a different reaction than baking soda. And you could see it in its raw state. It clearly wasn't baking soda. But it's interesting, the chemical world, isn't it? Any of you that have science backgrounds or the love of science and didn't know this, guess what? You just learned something new in the classroom. So I'm going to cap this stuff just in case it's releasing noxious fumes. We don't want that to happen. So I'll just show you, and it's kind of obvious. Where is it? This is our aluminum, and it's not ground up, but still, if you hit a pure metal of some sort with a chemical, if it's going to react, it's going to react, right? So I'll put a little bit of vinegar on this aluminum and just see if we get any reaction at all. We're not supposed to, according to the scientists on YouTube that are a lot smarter than me. Whoa, really hit it hard there, buddy. So it's not doing a thing. It's just kind of boring, isn't it? It's super boring. So no reaction to the aluminum to vinegar. Dry it all off, try to get that vinegar cleared off of there. Now we're going to hit it with a flame and see if anything happens when we hit it with a flame. Ready? I'll try my regular flame. Nothing? Try my torch. And I have to be careful because I did the grinding of the magnesium off of this machine on this carpet, so I might set my carpet on fire, but I've got my fire extinguisher just in case. Nothing. No reaction. So I'm going to set my aluminum to the side. Ooh, I'll tell you one thing though, it definitely is a conductor of heat. My fingers are going, hey, that was hot. That was hot, buddy. Okay, so now in the shot, we've got our one on the left that had the magnesium scrapings in it that we added vinegar to. There we are. And again, that's the result that we got from adding vinegar to the magnesium. Now in this same type of vial, we have some good old-fashioned baking soda. So I'm going to add a little bit of vinegar to that just so we can look at the two side by side and see how the reaction is different, as you might recall how it reacted to, how the magnesium reacted to the vinegar. All right, let's take the top off of that. Should probably take the top off this one too, just in case it's building up heat or going to explode or something like that, which wouldn't be cool. Okay, here we go. Let's add some vinegar to the baking soda, see what we get. It's kind of fun. Let's add a little bit more. I have to get a little bit more to add a little bit more. So a lot of bubble action, and then it goes clear. And there's no fumes coming off of it like the magnesium. We actually had fumes coming off of that magnesium when we hit it with the vinegar. This stuff kind of bubbled up the baking soda, and then it just went inert. The reaction stopped. I don't think it reacted quite as long as the magnesium, do you? Type in the chat if you think the magnesium had a slightly longer reaction time to the vinegar than the baking soda just had. The other thing is as well, you notice that the almost a charcoal blackened color that the magnesium gives us when it's introduced to vinegar. So that's kind of cool too. All right, I will cap these back up. We'll keep them on the bed of the machine so we can revisit them again. Because with chemicals, reactions can be delayed or they can be continuous. So we'll just see if anything else changes with these. Just curious. I'm a curious guy. All right, so now we're going to transition. We already hit aluminum with vinegar and with a fire source, no reaction. Now we're going to see what happens if we hit this larger quantity of magnesium shavings and scrapings with a fire source. Okay? Get nice and close to it. I do have the fire extinguisher within reach, just in case, just in case. All right, nice and close. Here we go. All right, here goes our fire source. You ready? It actually flamed up, folks. Did you see that? That was interesting. Let's hit it with a higher source of heat. My little clicker lighter, like you would use on a some sort of a grill, probably a couple hundred degrees. But let's kick up the heat a little bit higher, see if we get a better reaction from this if I hit it from the side with a torch. Again, this torch is gonna get right around 1,000 degrees. Let's see what happens. I'm gonna shut my fan off over there too. That seems to be causing us a... You see the sparking? And that's what magnesium does when it's hit by a flame. That's why I said you wouldn't want to be in a factory where they're making magnesium sewing machines if you have a fire break out. You don't want to be there. All right, that's enough. So we can confirm now that this FREE-WESTINGHOUSE, like some of the other machines you've seen on this channel, like the domestic ones that have the MG as part of their model number, that this is in fact magnesium. And magnesium, again, is going to be as strong as many steels, but it's going to be lighter than aluminum. There lies the advantage. What if they had made the Singer Featherweight 221 or the Singer Featherweight 222K, like we just saw both of those machines in Jean Van Dyke's premiere of her featherweight? What if they had made the featherweights on a magnesium instead of aluminum? Aluminum, they weigh 11 pounds. Magnesium, well, you could do the math. It would be about 33% lighter. So what would that be? About 3 pounds lighter, right? So the featherweight would come in right around 8 pounds instead of 11. How cool is that? Maybe we could talk to Singer, which now we know the parent company of Singer is based in Hollywood, California. Remember I posted that on Facebook? Let's reach out to them and say, hey, why don't you remake the featherweight out of magnesium? Okay, they might hang up on us the first couple of times, but then they might get intrigued and actually take our call. Don't you think? They might. They might take our call. You just never know. All right, you can take your safety goggles off now. We're done with our official experiments. And let's look again at those vials. The one on the right is the one that we had baking soda in. The one on the left is the one that we had magnesium scrapings in, and we hit it with vinegar. Look at the contrast. Isn't that interesting? That's just totally rocking cool. Yes, it is. So I got to get to work now on this FREE-WESTINGHOUSE machine from the 1940s. And it's going to be a job. Oh my goodness gravy, is it going to be a job. But that's okay. So there you go. Science 101 on the difference between the chemical response to magnesium and good old-fashioned baking soda. Oh, you know what I didn't do? I didn't do it. Is I didn't hit baking soda with a flame. What do you think will happen? Anything? We got to do it. We just got to do it so we know, right? Yeah, we do. Do I have any empty magnetic trays? Yes, I do. I have one right here. Let me just make sure it's clean. I don't want anything else in there. Baking soda. Where are you? There we go. All right, put your safety goggles back on, just in case. Just in case, you know what I mean? Zoom in on it. Good old baking soda, yeah. If this isn't science music, I don't know what is. Come on, let's turn it up. Oh, hey, Mr. Bean. Yeah, you can hang. It's close enough. All right, let's hit it with the regular flame. And then we'll hit it with the torch. Regular flame. Nothing exciting. Torch. Ooh, it kind of smokes a little bit, doesn't it? Can you see that? That's kind of cool. Yeah, it's not quite as dramatic as sparking, but it's still interesting. One, two, three, four. Sewing machine oil. It's got a very low flash point apparently, huh? Let's try it with a torch. Nothing. Let me try another chemical that I sometimes use. See how this reacts. I'll add it to the sewing machine oil. All right, this should be interesting. Fire extinguisher ready. Yeah, that burns. Oh yeah, a little bit. All right. Woo! That was exciting. That was like a gourmet program. Today on the cooking program. Yeah. All right, I'm done playing. I'm done playing. You guys are really curious what that was, aren't you? It's a special cleaning solution. Cleaning solutions can be very flammable, and that's why oftentimes on the container it will say that. Do not put by a flame. Don't do it. Don't do it. Well, thanks for joining me for this science class today as we kind of goofed around with different things, but we goofed around in a safe manner. And we had the fire extinguisher nearby just in case. All right, see ya. Watch for updates on this machine. Take care. God bless.